Sí, Elisa. Si puedes venir por aquí. ¿Así? Gilles, así se escucha bien. Para Marta y Elisa la altura también estará bien, así. Okay. Good morning, everyone, and welcome. My name is Gemma Roig. I'm responsible of FogGuru project at Las Naves, the Center for Social and Urban Innovation of the Municipality of Valencia. Las Naves is an entity depending on the municipality whose objective is to develop innovation, to develop city through innovation and focusing on improving citizens' lives. To achieve that, we use different tools, such as this one. We are participating in European innovation projects like FogGuru project. FogGuru is a project funded by European Commission within the framework Horizon 2020, and in the specific call, Marie Curie Actions Innovative Training Networks. With no delay, we are receiving the opening words of Marta Chillaron, the CEO of Las Naves, of Elisa Valía, the Conciliar for Integral Cycle of Water of Ayuntamiento de Valencia, and of Sebastián Lepicard, Vice President of European Projects of University of Rennes. We excuse the attendance of Sebastián because for COVID reasons he couldn't travel to Valencia, but he has sent us a video to welcome us to the event. Thank you very much.
Buenos días a todos y a todas. Como directora de Las Naves, es para mí un placer darles la bienvenida al Centro de Innovación Social y Urbana del Ayuntamiento de Valencia, Las Naves, donde somos personas innovando para personas. En primer lugar, quisiera agradecer a la Universidad de Rennes el haber pensado en Valencia como ciudad ideal para desplegar los demostradores del proyecto FogGuru. Agradecer a Ciclo Integral del Agua del Ayuntamiento y a la Marina de Valencia por cedernos sus infraestructuras para poder probar nuestros desarrollos, al resto de socios del proyecto por apoyarnos conectados online, la Universidad Técnica de Berlín, UHooper en Trento, Elastis en Uema y Aid Digital en Rennes.
Good morning, everybody. As CEO of Las Naves, I would like to welcome you and to express my pleasure that you are all here at the Social and Urban Innovation Center of the City Council of Valencia. We are people innovating for people. First of all, I'd like to thank the University of Rennes for having thought of Valencia as the ideal city to deploy the FogGuru project demonstrators, to thank the City Council's Integral Water Cycle and the Marina de Valencia for providing us with the infrastructures to be able to test our developments, to the rest of the project partners for supporting us online, the Technical University of Berlin, UHooper in Trent, Elasticis in Umeå, and EIT Digital in Rennes.
Me gustaría hacer una especial mención a nuestros 8 investigadores e investigadoras que son el alma del proyecto FogGuru. Me consta el gran esfuerzo que habéis realizado durante estos meses para sacar el proyecto adelante y el esfuerzo que aún queda por realizar, con la dificultad añadida de estar muy lejos de vuestras familias en las circunstancias sanitarias que vivimos actualmente. Por eso, hoy quería que mis primeras palabras fueran dirigidas a vosotros y a vosotras. Hoy estamos aquí para presentaros los demostradores que se han desplegado en Valencia en el marco del proyecto FogGuru.
In addition, I would like to make a special mention to our 8 researchers, who are the soul of the project. I'm fully aware of the effort you have made during all these months to move the project forward and the work that still remains to be done, with the added difficulty of being very far away from your families and in the challenging health circumstances we live. This is why today I wanted my first words to be addressed to you. Today we're here to present the demonstrators that have been developed in Valencia as part of the FogGuru project.
Durante más de 2 años, nuestras investigadoras e investigadores se han estado especializando en todos los ámbitos de la computación en la niebla o fog computing, una tecnología que agiliza y flexibiliza el proceso de datos y con ello también agiliza la resolución de problemas. En Valencia hemos aplicado esta tecnología en la infraestructura de Emivasa y el ciclo integral del agua, con el objetivo de monitorizar el consumo de agua y detectar fugas más rápidamente en nuestra ciudad, y así evitar el costo y el derroche que supone. Hace un año presentamos los objetivos de este proyecto, aquí mismo, este proyecto demostrador, y hoy, satisfechos con los resultados obtenidos, explicaremos nuestras conclusiones.
For more than 2 years, our researchers have been specializing in all areas of fog computing, a technology that makes data processing faster and more flexible, and thus also speeds up problem solving. In Valencia, we have applied this technology to the infrastructure of Emivasa and the integral water cycle of the municipality, with the aim of monitoring water consumption and detecting leaks more quickly, thus avoiding cost and waste involved. A year ago, we presented the objectives of this demonstration project, and today, very happy and satisfied with the results obtained, we will explain and present our conclusions.
Además, vamos a explicar el segundo demostrador del proyecto en Valencia, que acaba de comenzar. Se trata de un Fab Lab de Internet de las Cosas basado en fog computing. Estará terminado en marzo esta plataforma y será una plataforma en la que empresas, desarrolladores, estudiantes y, en definitiva, la ciudadanía podrán integrar sus propias fuentes de datos, compartirlas y reutilizarlas para sus propios desarrollos. La plataforma se utilizará inicialmente en la Marina de Valencia con el objetivo de medir diferentes parámetros ambientales y humanos, analizarlos y ofrecerle a la Marina nuevas soluciones para su gestión.
Moreover, we will introduce the second demonstrator of the project in Valencia, which has just begun. It is a Fab Lab of the Internet of Things based on fog computing. It will be finished in March and will be a platform where companies, developers, citizens, students, and in short, citizens will be able to integrate their own data sources, share them, and reuse them for their own developments. The platform will be used initially in La Marina de Valencia with the aim of measuring different environmental and human parameters, analyze them, and offer La Marina new solutions for its management.
Con todo esto, solo me queda resaltar la importancia que tienen los proyectos de investigación e innovación a la hora de mejorar la calidad de vida de las personas. Desde Valencia y a través de nuestra estrategia Missions Valencia 2030, tenemos claro que la innovación tiene que tener un foco humano. Y con esta premisa, Valencia está preparada para emprender un viaje colectivo hacia la innovación, colaborando con todo el ecosistema, ofreciendo la ciudad como laboratorio y dando a conocer el valor social de los proyectos desarrollados. Me despido agradeciendo a todos los asistentes y esperando que sea una jornada muy provechosa para todos y todas.
As a last word, I would like to emphasize the importance of research and innovation projects in improving the quality of life of people. From Valencia and through our strategy Missions Valencia 2030, we have no doubt that innovation must have a human focus, and with this premise, Valencia is prepared to undertake a collective journey towards innovation, collaborating with the whole ecosystem, offering the city as a laboratory and revealing the social value of the projects developed. I would like to conclude by thanking all the participants for your attendance and to wish you a very fruitful day. Thanks.
Good morning, everyone. Tout d'abord, je voudrais remercier l'Université de Rennes pour avoir choisi Valencia comme site pour le démonstrateur et pour les activités et pour pouvoir avoir le plaisir de travailler ici avec les PhD, les étudiants. Et bon, tout d'abord, merci, je vous remercie. Et en représentation de toute la ville. Valencia has been a city which has had traditionally a great sensitivity with the responsible use of water and always considering it a scarcity resource and a source of richness at the same time. That is why we have, for example, the Tribunal de las Aguas, a kind of water trial, recognized as UNESCO Intangible Heritage, which has been celebrating its sessions over hundreds of years, in which every Thursday its members are dictating sentences about the rights of use of water. Thanks to this spirit, and thanks also to the use of all the technology available, the city of Valencia has achieved technological milestones continuously over the last hundreds of years. The most recent ones are, in 2015, Valencia has become the first big EU city to have 100% of its net controlled with remote reading counters. Also, Valencia has been the first in creating a digital twin, which is a system that allows us to know exactly which is the state of the net, and also to act on it and simulate different scenarios before making any decision that may affect the net and the users from a remote centralized control center. We have also developed an app for end users with the information about consumption and also other issues related to the water supply. Nevertheless, far from being completely satisfied with this achievement of these milestones, we are continuously improving our infrastructures in the city and also in the metropolitan area. We are particularly focused on improving the security of the whole system of provision of drinking water to get prepared for future scenarios with less availability of resources and more adverse conditions and scarcity of water. While other cities are thinking now about implementing remote reading counters, Valencia is now preparing the replacement of the current remote reading counters by counters based on Internet of Things. The experience of Valencia is so robust that many manufacturing companies request the assessment of our experts for the development of the new products. This may be a reason for FogGuru being developed in Valencia, maybe. The FogGuru project, led by Professor Sébastien Le Picard, Vice President for EU Programs of the University of Rennes 1, is a clear example of collaboration between universities as academic entities and public local entities, which allows the early adoption of technology by the public local entities, while PhD students can have their first contact with a company or the local public entity. At the technological level, we have heard a lot, even the people without any specific expertise, about cloud computing, and may have also heard about edge computing, especially after the eruption of the 5G technology. But today, we will talk, and for sure we will learn, about a new concept, fog computing, which will bring at our disposal intelligence distributed in our net without the need to have great computational capacity in the final devices, and using instead the processing capacity of intermediate devices between the final device and the central servers. With the deployment of this technology, we will achieve greater rates of resilience and reaction speed in our net. So I would like to thank you for the work you have done so far, and I hope that we can implement and take up the technology as soon as possible. Thank you very much.
Hello everyone, buenos dias. First, I would like to apologize for not being with you this morning. I would have been very happy to participate to this great event. With a short video message, I wanted to express my congratulations and encouragements to the chorus team, and especially to the young researcher who reached really a very important step in the project today. And also, I wanted to mention that, as I already said last year, this project is really emblematic of the connection that can be made between basic research, innovation, and citizen. And that's really a great example of what can be made with research in progress and citizens. And with this second step opening up today, there will be even more involvement of citizens, and it will not be only science for citizens or to the benefit of citizens, but also science with citizens, as they will participate, be actors of the deployment and the development of the FogGuru project from now. So that's very exciting. Finally, I would like to thank all the partners, and especially the Smart City of Valencia, Las Naves, Emibaza, also for giving the opportunity to make this project to the whole team, but especially the young researcher, because I think that will be a very important step in their career. And so that's a very great opportunity to have this possible today. And of course, thank the academic partners, Technical University of Berlin, EIT Digital, and also the deep tech enterprises that are involved in the project, UHopper and Elasticys. So finally, and to be short, I just want to thank again, especially the coordinator of this project, Professor Guillaume Pierre, who is really a great coordinator, a great supervisor, I'm very sure of that. And I wish you the best for this day. It is very important for the project and for you all. And once again, from the University of Rennes 1, we are very proud that this project reaches this step and will deploy for the next year with very exciting new results coming up. Thank you. Bye-bye.
Thank you very much for this nice welcome and warm welcome from our representatives. Now we are going to deep into the more technical part of the event. I would like to see the agenda, please. During the first part of the event, we are going to, 1 year ago, we were here to show and to introduce the demonstrator at Valencia, the first part of the demonstrator at Valencia, which was fog computing applied to the management of water at the city. Today, in the first part of the event, we are going to explain the results obtained in this part of the pilot. And then we will introduce the second part of the pilot of the project, which will be demonstrated at La Marina de Valencia. Now, in order to introduce the event, we are going to receive Guillaume Pierre, which is the coordinator of FogGuru project, and he's going to introduce what's the meaning of FogGuru, what's the objective of the project, and the two specific living labs that we are deploying here at Valencia. Thank you very much.
All right, good morning, everyone. I would like to thank all the very warm welcomes and to thank everyone present here, to welcome the online audience, of course, and a very special thanks to Las Naves for hosting us as part of the FogGuru projects and for organizing the events today. So what I wanted to do today was to tell you a little bit about what is fog computing and how we have applied this technology for improving water management. I'm going to speak mostly about the fog computing, and the students will go into a little bit more details about the work they have done. So I'm not sure if yes. So fog computing comes from this understanding that the nature of data that people process and that enterprises process is changing. So this is a quote from Gartner, the American consulting company, which a couple of years ago realized that about 10% of the data managed by enterprises was being produced not in the big data centers, but elsewhere. And their prediction, and this prediction is becoming true nowadays, is that by 2025, 75% of the data will have been produced out of the data centers. So if data is not produced in the data centers, where is it produced? It is produced, well, mostly by the Internet of Things. So nowadays, we all have our smartphones, we have a lot of devices, the cities install a lot of sensors to measure lots of different elements of data. And this together is an enormous amount of data, and this amount of data is growing extremely quickly. So if we think about this from the point of view of the technology, we have on the left side the device, which produces data somehow based on something it has sensed. And we traditionally use the clouds to process the data, to analyze, to extract useful information out of the data that we have produced. Now, carrying the data from the device to the clouds can be a long journey. And in fact, in between those two things, we have the network. And the network may be a very, very long journey for data going from one place to the other. So if we think about this, and we think that a huge amount of data is being produced on the left side, then it becomes either not desirable or even not possible to carry all the data to the clouds to be processed and then trashed, because usually we don't keep the data, or we keep only a part of the data. So the idea of fog computing is that we're going to take additional computing resources and bring them very close from the sources of data. So this is a view of what a fog computing platform may look like. On the bottom, we have the devices, those things that produce data. Oops. And those things usually communicate their data using relatively short-ranged wireless networks like 5G, Wi-Fi, Bluetooth, and we're going to see today about the LoRa protocol. Inside the system, we have other types of networks to carry the data between the machines of the fog and towards the cloud. And those are fiber, DSL, Ethernet, 5G. On top, we have the cloud servers. They are very powerful. They can do a lot of things, but we can see they are pretty far from the devices. So the idea is to add those nodes in the middle that we see here, which are going to receive at least part of the data, process them, analyze them, and then either they may be able to react to something immediately by themselves and then autonomously react to certain events, or to transmit their data to the cloud, but this will be in much smaller volume. So what we're looking at in FogGuru is that middle part, the part that actually pre-processes the data before it reaches the cloud. So the cloud and the fog are very similar. They're not totally the same. In a cloud, so here on the left, we have a picture from a cloud data center. I think this one belongs to Google. Even the biggest clouds have not many of those data centers. I think Google has something like 20 distributed across the world. And each data center we see is a huge site with a lot of computing resources. So all those things in the middle are computer servers stacked with each other, and you have an enormous number of them over there. They are connected to each other and to the rest of the system, to the rest of the internet, using very high performance networks. And in cloud computing, it does not really matter where your applications are running. If your application is running on a machine on the left or the right or the front or the bottom of this data center, does not really matter. In a fog platform, what we're going to do is to distribute additional resources, so where the cloud will remain there, the cloud will not go away. And we're going to place additional resources close to the sources of data, close to the users, close to the devices, and that means everywhere. So they will be distributed in many different locations. And in each one of those locations, we will have just a small number of resources. So it could be this Raspberry Pi that we see on screen. The different points of presence will be connected with not the super high performance networks, first because it is very hard to bring those networks everywhere, and second because it is not necessary. What we will use is community networks, which means whatever you can find locally. If you have fiber connections, you use fiber. If you have DSL, you use DSL. Otherwise, you can use 5G and so on. And here, the difference with the cloud is the location of the resources becomes very important. It becomes very important because this was the reason why we deployed the fog in the first place. So the FogGuru project is funded by the European Commission, and it brings two universities, the University of Rennes 1, which is my university, and the University of TU Berlin in Germany. Two very deep tech companies. There is Elastisys here in Sweden and UHopper in Italy. EIT Digital is bringing training for the PhD students about innovation and entrepreneurship. And of course, last but not least, Las Naves, which is hosting us here today and which allows us to deploy the technologies and to test them in real settings. And this is a very important part of the project. So what does FogGuru do? Well, the goal of FogGuru is first to design and to invent new technologies for fog computing. It's a very young technology, not mature yet, and there remains a lot of research challenges that need to be tackled in order to build complete fog computing platforms. So the first goal will be to think and to design a general purpose fog computing platform, and the students will tell you a little bit more about it in a few minutes. And to design this, each one of them is researching a specific aspect of the design of those platforms. So I will not enter into the very technical details. The second thing is that having a platform is great, but we need to be able to deploy applications there. We want to deploy new innovative applications. So part of the research is also on designing the development environments, the environments where we're going to run those applications. And we have focused on one specific type of development environments called data stream processing middlewares. We're trying to build advice for new developers on how to design a fog computing application. It looks a little bit like a cloud application, but it also has specificities. So we are trying to develop guidelines on how should you develop a good fog computing application. And last but not least, we see this project as a way to train those 8 young, talented researchers and to give them the best opportunities for their future careers in developing and in promoting fog computing technologies. So in Valencia, we have started what we call the Living Lab, and the goal of the Living Lab was to take those technologies out of the lab, out of the universities, and to bring them in their city, to deploy them in real settings. The goal is first for us to validate the research by the students. We all know that you can do some very good research, have very good results in your nice little controlled environment, and this may or may not work when you face a real setting, a real deployed system. So we wanted to experiment in a large scale. We wanted to also use this opportunity to develop fog applications and to learn how those applications should be designed, so to develop those guidelines. The students are, of course, they are very strong technical researchers, but the goal here is also to increase their focus and to make them think also about the way their technologies are going to be used, the way enterprises may make use of those technologies. So this is an important aspect which is not purely scientific, but also increases the value and the impact of the work we're doing. We wanted to meet real customers and citizens because we know that those technologies disrupt a little bit the way the companies are operating. We know that the citizens need to be involved in the design of those systems. So this is really part of the value of what we find here. We wanted to benefit the city of Valencia. Of course, we are going to deploy our systems, and those systems, we hope, are going to be useful for the city and for the citizens. And last but not least, of course, this is a great opportunity for us to disseminate and to show the results of the project here in Valencia and today online worldwide, so to say. So we have worked during the first part of the Living Lab with this company called Emivasa, which is the public-private company in Valencia in charge of distributing drinking water to people's homes. So we see a picture representing, well, we see something where water is being produced and cleaned and then distributed in everybody's homes. And what is interesting is that for now a very long time, I think it has been done over the last 15 years. This company and the city of Valencia have deployed smart water meters, which of course measure how much water everyone has consumed. But very interestingly, they report those data through wireless technologies. So those data are available very quickly and can be analyzed, of course, to determine how much every customer should pay at the end of the month, but also as a tool for management of the whole water system. Like we can, for example, detect if there has been a leak of the water because suddenly the consumption of the water has an unusual trend. So what we have worked on is to increase this system and to think about the next generation of this system with more modern technologies and using fog computing technologies to process the data coming from the smart water meters. So the students are going to tell more details about this in a few minutes, so I am not going to enter too much right now. I just wanted to thank you, everyone, and on behalf of the FogGuru projects, to welcome everyone, and I hope this meeting is interesting for everyone.
Thank you very much, Guillaume. Now we are going to listen and to see the researchers that spent the first part of their secondment in our Living Lab, Dimitrios Giorokis, Hamid Reza Arkian, and Paulo Rodriguez de Souza. Please come, and if you want to explain the achievements you have got in Valencia, please.
Better. Okay, hello everyone. So I'm Hamid Reza Arkian, and I'm going to present our results. I'm actually the representative of the team. So yes, the other guys, especially Guillaume, talked about our use case, about the water management and what we have done here in Valencia. But I'm going to talk about more details. So yeah, we first focused on improving the water management system in Valencia by using fog computing technology in its architecture. So let me just sure. if I, no. Okay, yeah. Okay, so yeah, we focused on water management system because everyone know that in recent decades we have a lack of the water resources, and especially in some semi-desertic areas like south of Spain. We can see more critical situation about the water resources. So it became more important issue for citizens and for governments to manage better and better the water resources. Here in Valencia, in Mibasa, as Guillaume said, from 10 years ago or 15 years ago, we started to manage the water water management systems in Valencia, and they have developed more than 400,000 smart water meter here in Valencia, and these water meters use some wireless technologies, and yeah, based on I'm sorry. Yeah. Based on that system, MWASA can run some applications on this system, and they can use this system, for example, for detecting the abnormal water usage in the system, or if there is any leakage in the system, they can detect these problems, these issues in the system. And the system is working now, and of course it's useful, but however, it still has some problems, some issues. For example, it's dependent on the vendors. They use different water meters from different vendors, and the water meters are highly dependent to the vendors. And yes, they can detect the abnormality in the system, but the system is slow, especially for reactions to the water leakage and these things. And also another problem is that the complete system is closed, and it's difficult to change some part of it. And also, it's highly centralized. This means that they have a control center, and every data just come there, and then they can manage the data, and everything is centralized there. So they decided to use a new technology, a new wireless technology for their system. And they switched to LoRa technology, or LoRaWAN technology. And what is LoRa? In very simple words, LoRa is the abbreviation of the long range wide area. And LoRa is in fact a physical layer, it's a chip. And we have also LoRaWAN, and LoRaWAN is a software, is a MAC layer on top of that chip. And it can enable networking. It's like a wireless communication standard protocol, such as Bluetooth or Wi-Fi, and can enable networking in the system. So LoRaWAN has different characteristics that make it perfect for this use case, for water management and these kind of use cases. For example, the LoRaWAN is long range, and in urban area, its range is around actually more than 5 kilometers. In suburban area, even more than 10 kilometers. And its battery life of the chip, of the devices, is more than 10 years. For example, the water meters that the MWASA is already using has more than 15 years battery life. And it's very cheap. actually it's low cost, around $5 per module. And it's also has a low data rate. It's not a positive characteristic, but still it works for this use case, especially for the water management, because water meters just send a small size of packets every time. So it's really matched with this use case. And so, yeah, this is the architecture, the basic architecture of LoRaWAN. Well, you can see the water meters in the bottom of the architecture. We have many water meters deployed in the city. And they are connected to some gateways that they also deployed in the city. And they are connected to each other based on LoRa technology. And then the gateways send data to the upper layers. And upper layers are a network server, an application server, a joint server. All of these servers are part of LoRaWAN architecture. And then gateways send data to the network server with based on the 4G or LTE, actually the telecommunication networks. So yeah, this is the basic LoRaWAN architecture. It works, and it could be helpful for the water management, of course, but it's still there is some problem, especially in the middle of the architecture, when we are going to send data from the gateways to the network servers, to the actually let's say cloud side of the system. We need to use some telecommunication networks, and if we assume that we have enormous number of water meters that have been deployed in the city, so they are generating data, and they will send data to the gateway, and then this data should be sent to the network server. And so, yeah, this is the challenge of the basic architecture, because we have network delay. The distance between the water meters and the center, the control center, is a lot, and also 4G is not a perfect infrastructure for just managing this amount of data. So yeah, we focus on this middle part of the architecture and tried to improve it based on fog computing technology. As you can see in the new new architecture, that we call it Fog plus LoRa architecture. We use it, our fog nodes or fog servers close to the network servers, and put both of them together close to the gateways, somewhere more closer to the water meters. And yeah, we changed the middle layer of the architecture. And I'm not going to enter to more details, but yeah, in our fog nodes, we use different technologies, different applications to manage data there and to run the application, to process data. And we just send a small portion of data to the backend servers or to the cloud. So based on the new architecture, we have some benefits for the system, for the whole system. For example, the new architecture is fully open. We use open source applications, and it's not a vendor dependent system. It's not platform dependent, and multiple applications could run on the system. And in case of network failures, the new system is more robust and more tolerant. Because, for example, in the old system, if the network between the cloud and the gateways is failed, then we don't have data in cloud side and the data will lost. But here in the new architecture, we have the fog layer. It can keep the data and we can process data locally there. And we have a capability of monitoring and continuous monitoring and continuous management for the system. And also we have last mile processing power because we put our servers closer to the data sources, to the water meters. So we have the processing power much more closer to the edge of network, to the water meter layers. And also in cloud side, because as I told you, we process data in fog nodes. In cloud side, we have less load, less centralized system, and less administration, and of course, less cost in cloud side. Okay. This is the implemented solution. This is what we have implemented. As you can see, we have a water meter in the left of the figure, and the water meter is a LoRa-enabled water meter. It's a smart meter that can send data, the measurements of the water consumption based on LoRa. And it sends data to the gateway, a LoRaWAN gateway that can receive data, just forward data to the rest of the system. And then we have the fog nodes. We connect the fog nodes and gateway based on Wi-Fi. And in fog nodes, as I told you, we have different open source applications, especially CharperStack. We use CharperStack and also other applications there. We run the main application of water management there, and then we can process data, the measurements locally in fog nodes. And then we just send the processed data to the network server, to the backend server, or to the cloud. And then we have some dashboards in cloud side. We can show the results. We can show different measurements and in cloud side. So yeah, we also have a demo. Yes, it was not possible because the event is also live streaming. So it was not possible to have a live demo. So we recorded a short video about the demo. We will see it, and I will talk more about it. Hello, my name is Hamid Reza Arkian. I am part of a team that is working on fog computing technology and is using fog computing in water management system here in Valencia. I'm going to show you a demo about what we have done here in Valencia. Okay, here is the water meter. It measures the water consumption and uses LoRa technology to send data to the server or to the cloud. It can send data up to once in 15 minutes. But in our demo, we need more frequent data, so we use some artificial data instead. Okay, here is the application. It measures how much water we have consumed. It has two versions. In the first version, it uses cloud and sends data directly to the cloud. And in the second version, it uses fog, and it keeps data in the fog and just sends data only if there has been a change. Here is the application. We have both versions here together and some information about the device. About the water consumption, of course, they show same measurements for the water consumption, but about the number of messages, the FOG-enabled version sends much less data to the cloud than the FOG-disabled version. And in case of network failure, the FOG-enabled version can keep data locally and can process it locally, but in the cloud-based version will lose data. Here is the second dashboard. Here we can manage the devices. We can easily add or remove one device to the system. And we also can easily choose which device connect to which gateways in the system. This is the system management interface. It allows us to run multiple applications together, and we can easily deploy the new application and monitor the state of the application. So the prototype is now ready to be deployed. We hope to have a real-world experimentation, and I hope you have enjoyed the demo. If I can the presentation again. Okay, thank you. So let me just, yeah. Okay, as I mentioned, we hope to have a real experimentation, a real-world experimentation in citywide size in the Valencia. And for the conclusion, of course, this experiment, I think, I mean, the Living Lab had many benefits for us. Especially, we learned more to team working. We learned to work together, to some project management skills also. We learned how we should manage the project, the deadlines and these things. And also, because we were in touch with some non-technical people, not necessarily technical people, and we learned how we can work together with non-technical people, how we can understand their needs and like this. And also, the system also had some benefits for Emivasa and Valencian citizens, of course. And now they have a prototype that is working, and everything is ready for real-world deployment, and is completely ready for experimentation. So, yeah. Yes, we were three, Paolo, me, and Dimitri, that we worked on this use case on water management system in the first batch of the Living Lab. And here I would like to say thank you from the team, say thank you to Las Naves people, to the City Council, and especially to Emivasa people that really helped us and really care about our requirements, our needs, to have progress in our Living Lab time. Thank you very much.
Thank you very much. As explained 1 year ago, we met here and we showed you what we were going to develop here at Valencia in collaboration with the management of the Service of Management of Water of the city. Now, 1 year after, we are meet here and we are showing the results. Last year, we brought to this round table the same people as today, Guillaume Pierre, the coordinator of FogGuru project from the University of Rennes. Please come to the round table and have a seat, please, Guillaume. Alberto Palomar, the representative of Global Omnium, which is the collaborating company. Thank you. The collaborating company with the Services of Management of Water of the City Council of Valencia. Vicente Inglada, which is the secretary of the Consumers Union of Comunitat Valenciana, which is representing the citizenship, and Dimitros Giorukis, which is one of our researchers. Here we are going to talk. Here we are going to talk. Yes, we will need translation for Vicente, please. Yes, you can come and open the curtain if you want. Please come. Yes. As commented last year, we were talking here with these colleagues about the things that we want to develop at Valencia. We were asking ourselves what to expect, and now we are going to evaluate the results. Okay, we want to make these discussions collaborative and open, so I'm going to send you some questions. You are able to answer, but any of you can answer the questions I'm going to ask. The question will be directed to one specifically, but all of you can answer. Moreover, you can ask, the audience could ask your questions using the hashtag #FogGuru that you can see in the screen in some moments, so we will receive the questions from the YouTube chat, and we will ask our colleagues. So, please, my first question is to Dimitros, please. How can the real-world experimentation improve academic research?
How can it? Is this on? Yes, it is.
Yeah.
The question, if I understood, is how can experimentation help with academic research? I mean, it's part of it. We have to do it anyway in order to publish and in order to prove that what we're doing is actually correct. In this case, specifically for the lab, it was more like, what's the difference between living in a lab rat, basically, like as in an academia, and what's the real problems that people see outside of it? And that was the actual difference that we saw. For the research itself, as I said, it's the way to prove that you're right. And it's the only way, actually, to prove that you're right. So,
in your opinion, it's very important to test in a real environment because it's very different from the academy and from a closed environment.
Yes.
And what did you learn from this Living Lab?
Well, okay, you cannot account for pandemics. That's one thing. The other is that you have to have patience. And that is because, okay, you're a part of university, you're part of a team, and in order to communicate with people outside of it, it's not hard, but it takes time. In order to understand each other, in order to understand what we need and mutually move forward, basically. That's what we've learned. If it's personal research, it's way different. If it's in a team setting, it's another story that we found out here.
And now going deep into the more technical part of the use case, Alberto, please, could you explain us what's the most important benefit of fog computing technologies from your point of view to the water management in Valencia?
I think the most important thing is that you have the possibility of managing a distributed intelligence network. This way you can act more quickly to an event in the network that needs to be acted quickly, for instance. If not only the smart meters are connected, but also electromagnetic valves and so on, if a FogGuru node it detects that is a leak in a distribution network or pipeline, because the system is able to correlate the information of several meters, it can take decisions in local, not has to wait to the central server that maybe the algorithm is running by night and it's too late for action. So we have a tool to act immediately.
And in your opinion, what were your perspectives for real-world experimentations? What are your perspectives for real-world experimentation?
I think that this technology opened our mind, and we have to re-engineer all our distributed network with the intelligence in the network and not in the main server. So you can connect different devices that maybe nowadays are working in a standalone mode, and a meter knows what is happening with this customer. But a FogGuru node, for instance, can know what is occurring with 500 users. So has information to take more accurate decisions in order to manage the network. And the same for the distribution pipelines and so on. There are a lot of possibilities that open to engineers to design a complete network.
Thank you. And Vicente, now from the part of the citizenship, por la parte de la ciudadanía, después de haber escuchado los resultados del piloto y los resultados del caso de uso y cómo lo vamos a continuar aplicando, ¿crees que la ciudadanía se puede beneficiar directamente de esto?
Sí, en principio...
Could you translate again? Yes, the question is, if do you think that the citizenship could benefit directly from the results of this research and innovation project?
La pregunta es si la ciudadanía, que si opinas que la ciudadanía se puede beneficiar. Sí. Que no lo has entendido, ¿verdad?
Sí, sí, sí.
Vale, es que veía que asentía.
Ok. Sí, en principio, sobre todo, tenemos en cuenta, ¿no?, que FogGuru es un proyecto de innovación siempre al propio servicio de la ciudadanía, y entonces sí que tiene resultados positivos desde el punto de vista que sobre todo supone beneficios, ¿no? Nosotros vemos una serie de beneficios medioambientales y sobre todo también económicos para los propios ciudadanos. Y en ese sentido, este tipo de iniciativas y la utilización de los datos pues va a llevar sin duda a una serie de proyectos y de tratamiento que van a ser muy beneficiosos para los ciudadanos.
Y también, así desde el punto de vista de los ciudadanos, ¿crees que...?
Would you like me to interpret into English?
Sí, yes, please.
Oh, yeah. Yes. Thank you.
Desde el punto de vista de los ciudadanos, ¿crees que...? Ay, perdón.
Yes, sorry. Yes, in principle, as it especially takes into account the benefits and the advantages for citizens, FogGuru is a project that is at the service of the citizen. Therefore, it shows positive results in terms of environmental and economic benefits for the citizens as a whole, and these type of incentives and of initiatives we are sure that revolve around the use of data will lead to other projects that will be beneficial for all of us in Valencia. So.
Thank you. Now, I was asking that, estaba preguntando si crees que el fog computing debería permanecer ser impulsado desde la iniciativa privada como está siendo ahora mismo, o debería evolucionar hacia un modelo más gestionado más público.
Sí.
Espera.
Vicente, in your opinion, do you think that fog computing should keep on being fostered and supported from the private sector, or rather should evolve towards becoming a more public service?
Indudablemente, nosotros como organización de personas consumidoras siempre abogamos por un sistema público, pero no obstante creemos que en este sentido la colaboración público-privada es importante, ¿no? Es importante desde el punto de vista que creemos que la tecnología, al estar siempre al servicio de los ciudadanos, va a ser positivo, ¿no? Y en ese sentido, el trabajo conjunto entre universidades, grupos empresariales, el propio ayuntamiento, como es en este caso, pues puede favorecer desde el punto de vista de la eficacia pues la propia iniciativa, ¿no? Entonces, en ese sentido, yo creo que la colaboración público-privada sería mucho más importante para hacer un proyecto más general.
Thank you.
Yes, undoubtedly, we as a union of consumers, we have always and we will always defend a public service. However, we consider that we really need here a public-private partnership, and alliances of this type are really important because in all, technology should be at the service of citizens. So we need, as I said, a joint work with the universities, the City Council of Valencia, researchers, and all stakeholders to foster efficacy and the efficiency of the initiatives. So I insist on this collaboration, which is really very much needed.
Thank you, Viviana. Guillaume, could you contribute to this?
I just wanted to mention, so clearly the work we have done with Emivasa is rather something done for a single customer. So clearly Emivasa wants to deploy its infrastructure and basically have its own private infrastructure where they can process their own data. Now, this is what a lot of people are doing in the domain of fog computing, and almost all the initiatives nowadays are of that kind. But there's no reason why it has to be that way. So we can also think about this infrastructure as an infrastructure like a road network, like the water network, which is public property, where people can just make use of the infrastructure. And this is actually what we're going to try to do in the second phase of the Living Lab, the one which starts just now. So the goal will be to design a platform which will be open for a variety of usages, for a variety of users, such that anyone potentially may be authorized to come and to use this infrastructure. So this is for us very exciting, first because of the social benefits, and also because from a scientific point of view, it creates new challenges that are going to keep our students busy for a while.
Thank you. Dimi, do you have your personal opinion about this as researcher and seeing from the other side?
It's the same thing that we said in the first presentation when we closed it, and also what Guillaume said before, like FogGuru is about creating blueprints for applications. That means that those applications can be really different. It's not one customer. What we closed with in the very first presentation a year ago was that everyone should contact us. Like we're starting a platform, and that platform is open for anyone to use. It doesn't go into one direction, and it's there for people to build applications. The second batch is actually the proof of that people are there to actually develop something different on top of it. That's at least what I believed, and this is how we moved on with the project.
I see. And now, seeing from the point of view of the exploitation of the results of the project and bringing it to the business, Guillaume, what are the perspectives for exploiting the results of Living Lab from Valencia? At Valencia?
So clearly we're not doing this only for our own enjoyment, and we hope that those results are going to be useful. So the first exploitation perspective, the simplest, I would say the most immediate, is to actually transfer those technologies to Emivasa to support them in experimenting the technologies. We know it remains a prototype, so it is not a finalized commercial product, but we are really engaged in finalizing this journey together to transfer those technologies. Now, what is interesting here is that even though we have worked in very close collaboration with Emivasa, and we have used this particular use case as the driving force to lead our developments, we strongly believe that the same technologies can be reused in many other contexts. So this is an activity that will start now that the technology starts to be ready and usable. And we are going to promote the usage of those technologies. We are certainly going to release them in open source formats such that the broadest number of users may take those technologies, try them, challenge us, ask questions, give us feedback such that we can improve the work.
Mm-hmm. Thank you, Guillaume. And Alberto, do you have your own opinion about this?
Yes, as I mentioned before, the fact that...
The microphone, please.
Sorry. I say that, as I mentioned before, the fact that being able a new tool like FogGuru makes us to redefine the way we design a network. So there are new opportunities that we will try in field, first as a proof of concept, in which we will prove different facilities. For instance, we can check if we can use the FogGuru node to communicate to customers if there is an incident in the network, for instance, that the pressure is low, and we are working on it, and we send an SMS or a WhatsApp to the customers affected before they even notice that there is a lack of water in the home. So we have a lot of ideas with the security as first concern, that we have to be very sure that the communications are encrypted and unsecured, especially if we have to act over valves or systems that can be managed in remote. So we are thinking about several cases of use or in which FogGuru nodes are able to improve our network.
Thank you. And from the audience here, you can raise your hand, and if you have some questions for our experts, please. I encourage you to ask them. And from the remote audience, do we have some questions? I'm going to receive it in my phone, okay? If you have. My production team should send them to me. I have one. Do you think that the maturity of the technology is ready to be scalable at the whole city level? Maybe Guillaume or Dimi, or also Alberto? What do you think about it?
Dimi?
Yes, we think so. I mean, this was the idea from the very beginning, that you start with one neighborhood and then you move on to others. Slowly you reach the level of a city at some point. And that's the whole point of moving all the problems and all the computation as local as possible. So I think then you can just scale it to the level at least of a city.
Yeah, so right now the experimentations that we have done are very small. And in particular, they have been very small because of the lockdown, because of COVID, which did not make it very easy to try things in the wild. The system is designed to be scalable. The technologies are meant for this. The LoRa networks are meant for hosting a very large number of devices. And we have been very careful in the platform design to keep it scalable. So I would say all the conditions to scale at the side of the city should be there. We still need to demonstrate it. And this is something that I would very much like to do in the next month.
Perfect. We hope you can. Alberto, could you contribute something to this question?
Yes, as I said before, depending on in the case of use...
Microphone, please. Sorry.
Depending in the case of use, we have to be very cautious in application that act our distribution pipelines. So maybe for distribution pipelines is a little, we need more time to prove the technology, but for service to provide to final users information or service like that, I think that is usable right now.
Thank you. Please, the audience, I encourage you to send us your questions using the hashtag #ChatFogGuru. I think we have one more. Okay. Wait a moment. One question is, how have you worked with the data privacy, with the privacy of data that you have gathered? Has it affected to the citizenship or something?
It certainly does affect, and it should be there in the first place, not an afterthought. And actually, we took some time off in order to take care that things should not be leaking, things should be there for the people to be protected at the end of the day. And for example, Hamid took some time to actually investigate on a couple of sensors, and there we found different implementations of different encryption schemes. It's not that you can accommodate every type of it, but it should be there in the first place, and this was what we thought.
Yes, Guillaume?
So privacy is a property of the data. It's not a privacy of the platform which processes the data. Of course, the platform must do its part to not leak data, to not do bad things with it. But the privacy is first something about the nature of what you're processing, the data that you're processing. So here we're talking about, I would say, a relatively simple case where the data is being produced by the Emivasa company through their devices and processed using their own platform. So as long as this platform does not leak this data, then basically we're not different from the current system where Emivasa produces their data and they process them themselves, right? If we're moving to other use cases, then this is a question which is extremely relevant because all those IoT devices are designed to be close to the humans. They are designed to be close to human activities. So very obviously, there is a lot of thinking to be done when we design, when we install new sensors, new devices, to realize what are those data which are going to be produced, what are the privacy properties that must be attached to those data, and how to make sure that the platform actually understands and respects those constraints. So this is also work which has been started. So we have one PhD student over there who is working on those topics, and this is one topic that will become more relevant in the second part of the Living Lab, because there we will have more open data, and the data will be available to more people. So we have been careful to make sure that we will not collect very sensitive data, like, I don't know, a video camera which would film the people's faces. So this will not be part of the platform. But this is also a question that we're asking to ourselves as part of our research activities.
Okay, thank you, Guillaume. Vicente, Alberto.
No, in fact, in one of the first meeting we have, do you remember that all the radio transmission from the IoT device is encrypted, and in order to the FogGuru to deal with the data, the FogGuru has to disencrypt the message. So the keys for this encryption have to be stored in the FogGuru node. And one of the first concerns that we managed in the project was that keys have to be in a volatile memory in order that if the FogGuru node is stolen, because usually are stored in public facilities, the burglar has not the keys of the devices because it will be dangerous. So from the first time, security was our first concern in designing the FogGuru node.
Thank you, Alberto. Vicente, desde el punto de vista de la ciudadanía entiendo que la privacidad es muy, muy, muy importante. ¿Querrías añadir algo?
Sí, indudablemente el tema de la protección de datos y la privacidad es una cuestión de seguridad, y por tanto los ciudadanos siempre son muy recelosos de la utilización de sus datos, ¿no? En ese sentido, lo que tienen que hacer, sobre todo las propias administraciones, es tranquilizar a los ciudadanos y sobre todo, la utilización de buenas prácticas. Y esto principalmente con el tema de la transparencia tranquiliza a los propios ciudadanos, ¿no? Donde se le dé una cierta seguridad, ¿no? Entonces vivimos en una época en la que efectivamente los datos muchas veces suponen poder, y por tanto hay que explicarlo, y la información y la transparencia y las buenas prácticas hacen que los ciudadanos pues puedan estar seguros, ¿no? Pero no obstante, hay que trasladar esas buenas prácticas a los ciudadanos con información.
Gracias, Viviana, please.
Yes, of course, everything that has to do with data protection and data privacy is really important. Citizens need, but because it has to do with security. So citizens tend to be quite reluctant to give away their data freely, of course. So that is why public administrations should play a role in reassuring citizens so that they feel safe, they feel secure. They should make sure that those best practices are well conveyed, and transparency should be at the core of every action we carry out. The citizen needs to feel safe. Data imply power, and that power, the use of that power, has to be properly explained by conveying information in the proper way.
Thank you. Now we have a more technical question, which is what networking infrastructures are required to deploy this project? Can it be deployed in developing nations where there's only 2G or 3G cellular networks?
Well, the backbone of it is not just one protocol. We could also work with LoRaWAN, and we could also work with different protocols for that, depending on what you have available. It always has to have range at the end of the day in order to reach the nodes themselves. As far as connectivity goes, this is what covers it. As far as costs go, for example, this could be, it was already implemented in small-scale nodes with very cheap devices, Raspberry Pis, for example, and that could also help in order to deploy something like this in a developed nation.
So this is interesting because, as I explained a few minutes ago, a fog has two network systems. There's the networking system between the devices and the fog nodes. And we have been using LoRa, and we think this is a good system and a good protocol for this type of IoT devices. And then there is the second part, which is to allow the fog nodes to communicate with each other and with the rest of the internet. And actually, when you're in a situation where those networks are not extremely high performance, then this is where it matters even more to reduce the amount of data which is going to be transmitted over those expensive or not very high performance networks. So basically, this is a very good use case for the fog because it means that we can process data close to the devices and rely less on those long-distance networks. As Dimi was mentioning, the infrastructure is not expensive. The machines themselves are reasonably priced. I mean, we're using very small and very cheap devices for this. So we have never tried. We have never gone to, for example, developing countries to do this. But this is something that I would be very interested. So if the online audience, if the online person wants to drop me a message, I would be very interested to take this further.
So I encourage you to push Guillaume.
do it.
So, more questions from the audience? Yes, Dimi, and maybe before also you have commented that COVID has affected the project. how COVID has affected
Well,
your project?
one person of the project spent 3 months in a couch.
This person.
This person. In another country that didn't have a house, probably, because there were no flights. That didn't stop us from just continuing moving forward with meetings online and all that, but it certainly affected the speed mostly. The willingness, no, but the speed itself, yes.
Yes, and I will extend the questions because, Guillaume, could you explain how we solved the problems about COVID with the European Commission?
So clearly the COVID has affected us in many ways. Clearly those students present in Valencia, well, one of them got stuck in a different country and stayed there for 3 months, but even those who remained on site were locked in their home. So if we're talking about teamwork, this is not helpful, right? So fortunately, we are in one of the professions where we are more likely to work remotely, and we master the video conference tools, these kind of things. Now, the one thing that became extremely hard to do was experimentation. Because for experimentation, you need to go somewhere and to actually connect the water meter to a water tap. So this operation, this very simple operation, is something that we have done only a few days ago, and the tap is somewhere there, outside. So it has affected the work of this group. The other thing was that we were supposed to start the second part of the Living Lab in June, right after the first batch. And this turned out to be totally impossible, right? So already for those students in Valencia to move to other countries was difficult. For people in other countries to come here was just impossible. So we had to reschedule the task. We had to reschedule the experimentation. Now it has become possible for 3 students from the second group who are here today, so they are studying their own projects. One of them is having visa problems, and the visa problems are also a consequence of COVID because the embassies process the visa applications much slower than usual. So clearly it has affected us. It has not changed our determination to carry out this experimentation and to carry out this great project. But clearly, this is life, right? You have unexpected things happen, and this one was more unexpected than the normal unexpected. And this is also, I think, a great learning experience for the students to experience firsthand, how do you deal with a project when not everything goes exactly according to plan? And to reorganize and to change your mind and to reschedule and to change a little bit what you're delivering. So let's say it has been a great learning experience. I hope we don't learn more about this, and I hope the epidemics will stop very soon.
Thank you, Guillaume. We have suffered it.
It was interesting.
Yeah. And for Vicente and Alberto, I would like to extend this question and ask yourselves how COVID crisis affected your own businesses, and how do you think that research and innovation could help you? Maybe, how do you think that maybe Las Naves could help you to solve or to resolve the main issues you are suffering because of COVID?
Sí, en principio hay que, claro, la situación, ¿no?, del COVID para los propios ciudadanos nos ha producido, pues eso, cierta inseguridad, ¿no? Y en ese sentido, este tipo de iniciativas, sobre todo en el que desde el punto de vista tecnológico se puede trasladar información de una manera no presencial, pues al ciudadano también le puede tranquilizar, ¿no? Y en este sentido, desde el punto de vista incluso laboral, ¿no?, el teletrabajo pues, abre muchas posibilidades, ¿no? Y este tipo, por ejemplo, de proyectos también, de utilización de datos y de costumbres, pues también abre unas nuevas oportunidades para los propios ciudadanos. Pero en principio lo que sobre todo trasladan es una cierta seguridad ante este tipo de pandemias, ¿no? Y en ese sentido, pues si se destaca algo positivo, que desde luego no se puede trasladar, ¿no? Pero si hay algo es que se van a generar una serie de usos y costumbres que pueden ser positivos para el trabajo en un futuro.
Well, yes, this COVID situation has implied many challenges for all of us, for citizens as a whole, and this entails a certain degree of uncertainty, lack of security, of safety, as I said before. So any type of project of initiative that allows to transfer info remotely that doesn't require the face-to-face interaction will be beneficial for citizens, for all of us, and it will make our lives easier. And from the labor market point of view, teleworking opens up new possibilities, new uses. So if we can extract any positive thing, anything that is beneficial from this pandemic, is exactly that this will lead and pave the way for newer uses, new habits that can be useful and that can provide some advantages too.
Alberto, please.
In our case, speaking only in terms of professional, okay, I think that it has been even positive, the experience, because we have had time to improve our inner processes, so our productivity has rocketed. We have tested that cities where we have implemented IoT solutions, the performance of the tele-reading of smart metering have even improved along the lockdown, because working in remote we have been able to improve the performance, whereas with other technology that has a lot of dumb devices in the street and we cannot operate for at least 2-3 weeks, the performance drops. So this is reinforce our idea of migrating to IoT solutions in tele-reading. And from the point of view of user, Vicente, maybe you have heard of another Mediterranean city, I don't will say the name, but it has had a lot of problem with water meter reading, that you have heard anything about it in Valencia. So it's the best proof that the system works and it has benefits to citizens.
Thank you. I think that we have not more questions for the audience, but we'd like to close this roundtable asking a question from myself, which I think that is the most important, but I think it is also the most difficult to answer, because as you maybe know, from Las Naves we used to develop research and innovation projects. We analyze and we measure the results of these projects, and for sure we find a lot of benefits for the citizens, a lot of benefits for the city, but the European Commission has done different research, and they have noticed that the social value of innovation doesn't arrive to people, and people doesn't perceive that research and innovation could improve their lives. So, Vicente, esta pregunta es para ti. How do you think, ¿cómo crees que podríamos hacer llegar la investigación y la innovación a las personas?
Sí, yo creo que iniciativas como estas son muy positivas, pero tú lo comentabas, ¿no? Las instituciones europeas, la Comisión Europea, ve la innovación, y así lo vemos todos, ¿no? Que siempre tiene que estar al servicio de la propia ciudadanía, ¿no? Entonces te piden, y de hecho es un valor añadido, por no decir obligatorio, la justificación ciudadana de cualquier proyecto, ¿no? Y en ese sentido lo que hay que trasladar, que el resultado final, independientemente que sea un avance tecnológico, tenga unos beneficios que puedan ser directamente palpables y puedan ser vistos por parte de los ciudadanos, ¿no? Y que los ciudadanos puedan tener un beneficio, ¿no? Entonces esa innovación al servicio de la ciudadanía es totalmente necesaria. Está claro que se puede, desde el punto de vista tecnológico, podemos avanzar mucho, pero todo aquello que no conlleve una serie de beneficios para los propios ciudadanos, no, independientemente que económicamente pueda ser muy útil para las empresas, no va a tener ningún sentido. Entonces, a partir de ahora, cualquier tipo de proyecto tiene que tener siempre un fin social. Y eso es lo que estamos demandando, y de hecho yo creo que la Comisión Europea va en la línea acertada, ¿no?
Viviana, please.
Yes. As you said, Gemma, the European Commission and the different EU institutions stress the fact, the idea of innovation being always at the service of the citizens. This has been an added value and a precondition, so to say, an obligation that any project, any initiative must prove and demonstrate a social value. The final result has to show benefits that are tangible, that can be seen by the common citizen. There should be a clear advantage for them. So a lot can be done from the technological point of view, many advances and can be done, but the citizen must see and understand the benefit. Otherwise, they will be pointless. So we demand from the unions, from the consumer organizations, exactly that, what the EC stresses. Anything has to have a social aim and a social benefit.
I think this is very easy to say. This is complicated to achieve, and I think that it's very important that we could keep working together in order to find this achievement.
So maybe I'll give my take on this. So first, thank you for the very horribly difficult question. But it's a good question, because I agree, and this is the goal. The goal, I'm a professor, I'm a researcher. My personal enjoyment at developing science does not matter. What we need to do is to actually bring those technologies and those innovations for some social benefits. Now, it's a very long process, because we start from core research on technologies which are, we are in a field of science which is not directly visible to customers, right? If you work on, I don't know, computer graphics, then you can see the outcome of some research in a very easy way. We're not in that position. So it is a long process to develop the research, to involve companies, to involve deployments, going and providing some tangible benefits to the citizens. And the last part is to actually make this visible to the citizens, right? So the further we go from the technology to the citizens, the less grip that we have as researchers to do it. And we actually rely on the companies, and I'm very happy to have a representative of the citizens, because we also rely on you to do those last steps, because you know the citizens, you know the local environments. What do I know about communication with the local people? So we really need those relays, and I'm really glad to have you here today for this.
Thank you, Guillaume. The point of view of the academy is very important also in this part. So just for wrapping up this roundtable, I would like to highlight some conclusions that there's a big difference between testing in a closed world and in a real world. We have some achievements and some good results of this use case, but we have a long way to run, a long way to continue. We have to work around the exploitation of the solution we have developed. We have to assert the privacy. We have to continue to enlarge the project to a district or a specific part of Valencia. For sure, the research and innovation could improve people's lives. Let's demonstrate it. So thank you very much. Thank you, the speakers, very much. Now we have a short break, 10 minutes, and we will come back explaining the second use case that we are going to demonstrate at Valencia, which is be placed at La Marina de Valencia. Welcome back, everyone. Now we are going to explain the second use case we are going to demonstrate at Valencia. This case is going to take place at La Marina de Valencia, which is the harbor of Valencia. And here we have Manuela Gras, the head of planning and infrastructures at La Marina, and Guillaume Pierre, the coordinator of FogGuru project from the University of Rennes. They are going to explain what's the use case about.
Hola a todos. En la Marina estamos encantados en colaborar en proyectos como este de FogGuru. Para los que no conozcáis la Marina de Valencia, nos situamos en el puerto histórico de Valencia, hoy transformado en un espacio abierto destinado principalmente a la innovación y a la actividad náutica.
Hello everybody. At La Marina de Valencia, we are really happy with the possibility of collaborating with projects such as FogGuru by making our facilities available. For those of you who don't know us, La Marina is the historic harbor of Valencia, nowadays converted into a public space open to innovation and nautical activity.
La Marina se sitúa entre el puerto industrial y la playa de las Arenas, y heredó las infraestructuras de una serie de eventos náuticos muy importantes como la Copa América de Vela y otros eventos como el Gran Premio de Fórmula 1. Hoy, la Marina es la institución encargada de desarrollar y repensar y reutilizar estas infraestructuras, con el fin de maximizar el potencial cívico, comercial, ecológico y cultural del espacio.
Located between the industrial port of Valencia and the Las Arenas beach, La Marina has the legacy of several grand-scale projects, such as the sailing competition, America's Cup, and the Formula 1 Grand Prix race. Today, La Marina is the institution responsible for managing this space, and it has embarked on a mission to rethink and to reuse the existing infrastructures in order to maximize the civic, commercial, ecological, and cultural potential of La Marina.
La Marina, que es esta imagen que tenemos en pantalla, en datos sería 1 millón de metros cuadrados, de los cuales la mitad de ellos son agua de mar. Tiene 820 amarres, espacios dedicados a la educación y la innovación, incubadoras y aceleradoras de empresas, restaurantes, clubes deportivos y edificios y espacios polivalentes.
The Marina, and you can see it on the picture on the screen, has 1 million square meters. Half of them are seawater. It also has 820 berths, spaces dedicated to education and innovation, fintech incubators and accelerators, restaurants, sports clubs, federations, companies, and multipurpose buildings and spaces.
Desde la Marina tenemos el propósito de apoyar la innovación tanto de productos como de servicios. Por eso, para nosotros, el concepto de Marina Living Lab es importante. Un espacio que apoya la innovación, abierto y que reúne grupos de gente diversa como vosotros para pensar sobre diferentes necesidades o ideas.
At La Marina, we have the purpose of supporting the innovation of products and services. That is why we want to promote the concept and the idea of La Marina as a living lab, a space that supports innovation, an open space that brings together groups of diverse people like you with different approaches to think about several needs or ideas.
Por eso, programas como este nos ayudará con un paso básico y fundamental, a medir y analizar datos. En esta etapa, de forma coordinada con el programa, se propone instalar diferentes sensores que se adaptarán a las características y la singularidad de nuestro espacio y que medirán, por ejemplo, corrientes y flujos de agua de mar, la calidad del agua, la calidad ambiental, la dirección y velocidad del viento, movimientos de flujos de personas, tráfico, etc.
That is why this program will help us with fundamental steps, that is, to measure and analyze data. At this stage, and in collaboration with this project, we intend to install sensors that will be adapted to the characteristics and the uniqueness of our space, and that will measure, among others, currents and flows of seawater, water quality, environmental quality and particles in the air, wind direction and speed, influx, movements of people, traffic, and so on and so forth.
Posteriormente se desarrollarán aplicaciones sencillas donde se utilizarán estos datos. Y en base a esos datos reales se evaluará qué se puede mejorar y cómo. Sobre todo aplicándolo en nuestras instalaciones. Y, por supuesto, daremos espacio a la creatividad y a la participación de diferentes comunidades.
Later on, simple applications will be developed where this data will be used. And based on the real data obtained, our researchers will assess and evaluate what can be improved and what can work better. Of course, always giving room to creativity and allowing participation of different communities.
Gracias por estar con nosotros y por vuestro tiempo.
I conclude with this. Thank you for being with us and for your time.
Right, so I apologize. I think I speak too much today, but I promise this is the last time you hear me today. So basically, I'd like to go a little bit into the objectives of the second use case that we're going to develop together with La Marina. Just for those who have not had the chance of visiting La Marina, it's a really nice place. So we see, of course, this is a place where people can keep their pleasure boats. But this is also a place where people can enter and have a walk. And also we have cultural events. And this is really a living place where we expect that people are going to come and have a pleasant time. So what we're going to do, well, the idea is very simple. We're going to take IoT devices. We're going to deploy fog computing, of course, in La Marina. And the objective of this, we have multiple objectives. The first one is for La Marina. We hope that this is going to first allow La Marina to address a few very specific questions that they have about the management of the spaces. But the greater goal for them is to increase the attractiveness of the place, to bring more people, to bring more activities, and to make this a living place. Of course, for us, we're very happy to participate in improving the attractiveness of La Marina. But for us, the first goal is, again, real-world experimentation. I mean, we have discussed before how important this is to take the technologies out of the labs and bringing them to the real world. It's a good support for research, and the fact that we have a deployed, or that we will have a deployed fog, allows us to conduct research that may not have been possible otherwise. It's a great learning experience for the students and for myself, by the way. And also we hope to achieve social and technological impact. Las Naves has a mission of promoting social innovation and technological innovation. And last but not least, for the Valencia citizens, we're going to try to open the platform such that they can come and learn how to use the fog platform. So this is not just a platform which will be there and we will tell people that it exists and that it provides a number of benefits. But this is also something where we expect that people are going to come and play with the system themselves. The second thing is that we hope that this initiative will allow us to develop a lot of innovative applications which are going to be useful for the local citizens. How are we going to do this? Well, this whole use case started with a discussion where I was asked, like, could it be possible to create a Fab Lab? So for those who don't know what is a Fab Lab, this is usually an open space where anyone is welcome to come. This is really an open door environment in order to develop their projects. And those are usually fabrication projects, so to build physical objects. So those are spaces where you'll find 3D printers, laser cutters, tools to do electronics, and these kind of things. What we want to do is to do something very similar, but not in terms of fabrication of objects, in terms of development of applications, about how would people come to invent new usages, new applications, new ways to deliver value out of the data. So we want this place to be an open location. We are going to bring open data to that place. So we are going to deploy sensors, and the data coming from the sensors will be available for anyone who wants to use them. We will open the Fog platform, so members, people who want to join, will have access to the platform, will be able to develop their applications, to deploy them there, and to experiment firsthand what it means to actually use a Fog platform. And in the spirit of the Fab Labs, and in the spirit of the FogGuru projects, all of this will be based on open source technologies with a collaborative component. So the idea is that people come and help each other, and we are going to assist them, and to really create this mentality of mutual help. We expect different populations of users to come. It could be students, for example, from the local universities, who may want to come and to actually try fog computing platforms, try those technologies, and to learn from this. Could be entrepreneurs, companies who may want to either validate whether those technologies answer their questions, but they may also want to actually design the actual applications because they would like to deliver some service to their customers. Could be citizens, anyone entering because they would like to try. So really the idea is to be as open as possible. We are going to deploy a number of devices, a number of sensors. I will not go myself into the details of this, but the students will present after me and will show what they plan to do. Of course, we will deploy a fog computing infrastructure, deploying programming environments to support new users and to allow new users to design something, to try something, to test. And we hope that people, of course, we will be the first users, but we really hope that other people are going to come and to play with the system. Why would you do this? Because you want to learn, because this is fun, because it's a way of sharing data with others, because it's a way to deliver innovations. It may be also a way to deliver business. So for users who may not be very highly technical, we are going to provide simple programming environments. And this is one example. It's called Node-RED. And it's a way to design data processing pipelines out of standard components. So each of those little elements on the screen are standard components, and we can just compose them together in order to build an application. That means that we can deliver an application without writing a single line of code. If we have more advanced users, so this has great benefits, but also a few limitations. If we want to support more advanced users, we're going to provide more advanced environments, and this one is called Apache Flink, such that more sophisticated applications may be developed. Here, the developers will need to know how to program, will need to have the right background, right? So we're trying to address those different populations. Last but not least, we're planning to organize a hackathon. So the date is not scheduled yet, but I presume it should be somewhere around January or February, somewhere around there. And the idea will be to invite teams of developers, local ones, but we also hope to be attractive for people to come to Valencia to participate in this event. And again, open the data, give them access to the system, give them access to the fog, and launch a challenge to develop, to invent the most innovative application based on those data, based on that platform. So it's a way to promote the platform, it's a way to bring people here and to show them the good work that the students have done in collaboration with La Marina. So that's all for me today. I would like to thank the audience, and I'll leave the floor to Gemma, who will introduce the last presentation.
Thank you very much, Guillaume. And our last presentation is about the more technical part of this second use case at Valencia, and our colleagues Davador Batulga, Mosde Fajardi, and Muluyeta Tamiru have prepared this presentation. I think Muluyeta is going to speak.
Okay. I am Mulugeta. I am one of the 4 early stage researchers or PhD candidates from the FogGuru project, along with Dava, Mojde, and Lily. And we are going to work on this IoT and fog computing project at La Marina de Valencia. So we are very excited to work in this interesting project, and especially here at Valencia. So the main objective of this project is to deploy several sensors throughout La Marina de Valencia to measure important parameters such as sea wave levels, weather conditions, number of people, and water quality. And we will also deploy a fog computing infrastructure to enable processing of this huge amount of data in real time. What makes this project a little bit different from the first one is that we are going to deploy several types of sensors, and this project will integrate, it will not only generate a diverse and large amount of data, but it will integrate several state-of-the-art technologies such as Internet of Things, long-range wireless technology, fog computing, Raspberry Pis, and Kubernetes. Let us look here at what the deployment will look like. So on the left, we have the sensors here. So this is one of the different features from the first project. Here, we will have several sensors to measure sea wave conditions, weather conditions, wind, water quality, number of people, number of cars that are coming and leaving La Marina, and indoor environment. So these sensors will send the data that they measure to the LoRaWAN gateways. We'll have several of these. And they will use the LoRa long-range wireless technology for this. The LoRaWAN gateways, in turn, will send the data that they collected from the sensors to the fog computing infrastructure over local area network, over cable, or over Wi-Fi. The fog computing infrastructure itself is made up of several small computers called Raspberry Pis, and we will use Kubernetes open source project for resource management and application deployment. Then the users, for example, at the Fab Lab or at the Hackathon will deploy. We expect that they will deploy several applications in a distributed and scalable manner on these cloud computing infrastructures. That way, we will be able to process the huge amount of data gathered from the sensors in real time, and we can get some insights within seconds. Some of the aggregate data will later be sent to cloud servers for further processing or for long-term storage. We will also use cloud servers for additional resources whenever we run out of resources at the cloud computing level. Sorry. Let us now look at some of the sensors one by one and show where they will be deployed inside La Marina. So the first sensor that you see up here is called an acoustic Doppler current profiler, or ADCP for short. So this is actually a big device that will be placed inside the sea, and it will make it possible to measure parameters such as the height of the sea wave, the water pressure, the velocity of the water, and temperature, and many other parameters in a very, very detailed manner. This device is not actually capable of sending data wirelessly over LoRaWAN, so we have to equip it with another LoRaWAN converter to be able to send the data to the LoRaWAN gateways. The second set of sensors is a wind sensor and a weather station. So there is this building here called Veles Events. There we will deploy 3 wind sensors on the corridors of this building. This will give us an idea of how wind impacts the structure of the building. Up here we have a weather station that will be deployed right outside of this building, and it will enable us to measure weather conditions such as temperature, humidity, and rainfall levels. Next, we have the water quality sensor. This will also be deployed in the water. It has probes which go inside the water to measure water temperature, pH levels, oxidation level, and other chemical properties of the water. The next set of sensors are these people counter. So this solution is, we selected this solution intentionally because it is a cameraless solution using radar technology. So this will ensure the privacy of visitors at La Marina. So this will be deployed in some of the buildings here and in some open areas where people access La Marina. And it will give us an idea of how many people are visiting La Marina. The next set of sensors is similar to the people counter, but these ones will count the number of vehicles which are coming and leaving La Marina. The last set of sensors will be deployed inside some of these semi-open buildings where cultural events take place, people come to just enjoy. And these sensors will be placed indoors and they will measure ambient temperature, humidity, and air quality. So to collect the data which is generated from the sensors, we will deploy these gateways. So we will have 2 outdoor gateways which will be placed outside in open space, and we will have these indoor gateways which will be co-located with sensors in some of the buildings. And last but not least, this is also an important part of this project, we will co-locate these fog computing clusters along with sensors. So we expect that the vast amount of data and variety of data that will be generated from these sensors will be used for several applications. Here we list just a few of those possibilities, some applications and use cases. First, we expect that La Marina itself can use the insights gathered from this data for improving their services, to improving the efficiency of their asset management. Second, it is possible to develop mobile and web applications that display information, accurate and real-time information for yachters and visitors of La Marina. This will also help, let's say, a reservation system for the mooring berths in La Marina. Third, it is also possible to have displays where real-time data will be provided for visitors of La Marina so that they can plan their stay at La Marina and make the most out of it. Last, there is also a possibility to make this data available for the wider community through open access to university students, researchers, startups, and so on. And that will make it possible for the wider community's innovative and interesting solutions. And we also expect the Fab Lab and the Hackathon events where people will come and use this infrastructure to come up with interesting ideas. For us, the FogGuru researchers, this is also an interesting opportunity. As Professor Pierre mentioned earlier, it will give us an environment outside of the controlled lab environment. This is a real world, a real application environment where we can test the methods and results from our respective research projects to validate our ideas, to understand what can be improved, and so on. So we are a team of researchers, an international team coming from all over the world. So Li Wu, who is not here today, is from China. I myself am from Ethiopia. Dava over there is from Mongolia, and Mojde is from Iran. Now I'll talk a little bit about our respective research projects and how we will benefit from this experience at La Marina. Li Wu's research focuses mainly on coming up with automatic ways of identifying failures in distributed fog applications. So she is designing mechanisms for identifying faults in distributed and latency-sensitive fog applications and ways to recover from abnormal state back to normal state. So she expects that in the setting at La Marina, in the fog computing infrastructure, we will expect that several applications with complex interactions will be deployed, and that will give the opportunity for several kinds of faults to emerge. So she can use her methods to identify these faults and to improve the application deployed on the infrastructure. My own research focuses on autonomous resource provisioning and stability management of the fog computing infrastructure. I have been working on some methods for automatic ways to improve the stability of the fog computing infrastructure, in spite of the fact that many applications are deployed on the infrastructure and the demand for applications varies throughout the day. So we have to make sure that the stability of the system remains the same, remains high and the same at all times. I'm also working on methods for automatic resource provisioning, meaning that enough resources should be provided for users even though the demand fluctuates, while maintaining high quality of services and minimizing costs. So I will also benefit from immensely from this experience, in that several applications and several users will be using the fog infrastructure, creating many interesting use cases where I can validate my own research results. Next, Dava and Mojde will tell us briefly about their respective research projects and how they will benefit from this experience at La Marina.
Okay. So, hello, I'm Dava. I'm a PhD student of University of Rennes 1 and also research engineer from UHopper. So my objective here is focused more on building a data pipeline. So data pipeline is basically the process or software structure from collecting the data until generating any result. So, which means it's I'm focused more on software point of view of this project. So, as our colleagues mentioned, one of the FogGuru project, well, goal of the FogGuru project is that for students and data enthusiasts and software developers or the citizens to build their own application and deploy their application using our fog environment. So idea is to let everyone deploy their fog application without even knowing any software programming skills or programming language. So in order to do that, I will focus more on enabling the data discovery or enabling the resource discovery, and also I will focus my work more on deploying and writing lots of APIs to easy deployment of the fog applications. And also, as our colleagues mentioned, we are planning to organize a hackathon in the beginning of next year to attract students and citizens to test their innovative skills and select some of the softwares they wrote. And also, from my point of view, for my research objective, for my research topic is the scalable data pipeline. It will benefit from the real-life infrastructure from La Marina, and also the data it will be generated. Thank you.
Hello, everyone. So we are going to have a lot of applications, and we are going to launch a hackathon to encourage citizens to provide us various applications. So that is really great. But what if some of these applications do not respect the privacy of our citizens. What if in our great La Marina Fab Lab project, we have some data breach? No, we don't want such thing happens. My PhD thesis is about automatically monitoring the applications to see if these applications are respecting their privacy policy claims. I'm going to use the fog computing clusters to deploy some monitoring services that are going to unintrusively observe the behavior of the applications and understand if these applications are respecting the privacy of their application's user. So this La Marina project is very interesting for my research because I will have access to a lot of applications that are deployed by various companies, citizens, programmers. And on the other side, I believe that my research would be very beneficial for this project. Thank you.
So to conclude, we will have this IoT and fog computing project coming up. It has already started at La Marina de Valencia. And La Marina will be equipped with several sensors and fog computing infrastructure. We expect that La Marina and the citizens of Valencia will benefit immensely from the data generated from this project. And last but not least, we, the FogGuru researchers, will benefit from this experience by validating and improving the methods and solutions proposed in our respective research. Thank you very much.
Thank you all. Just to comment, if you have some questions or doubts, you can raise your hand and ask. If we can receive the questions from the audience in the chat FogGuru with the hashtag. And we are not receiving questions. We are going to close. Guillaume, would you like to say some words to close the event?
So just very briefly, I wanted to thank again everyone who participated in this event today. And first of all, Gemma, who has been fantastic. I mean, thanks a lot for organizing this. And thanks to Las Naves for having us. I hope that we have given you a clear view about the current status of the work in the FogGuru project. So keep following us, and we will, of course, have much more news in the months to come. So thanks a lot.